Now let's take a look at number 3. Now, this one's going to be different from what you guys have. Here I had 120 students. On your sheet, it should be 40 students. And I changed that for a really good reason. Because out of 120 students, we're going to have a really big number. And let's just try to keep our numbers a little bit small if we can, right? So a service organization on campus needs a group of 6 students from their organization's membership of 40 students to serve as program attendants at graduation. And how many ways can the attendants be chosen? Oops, I didn't mean to cross it out. I was trying to underline it. I'll fix that. Okay. How many different ways can they be chosen? So once again here, order is not mattering. Once you pick the people you want to be attendants at the graduation, it's the same people. No matter you pick this one dude first or you pick that other girl second. It doesn't matter. They're still part of the group that are going to serve at the graduation. So order does not matter. That means it's a combination. So with this one, notice we got really big numbers. We have 40 students, but we're only taking 6 of them. And actually, we can write this one out. For a second, I thought we couldn't draw a picture, but we can. It's still going to be pretty big. So 6 students. So we're picking out 6. For the first student, there's 40 options. For the second student, there's 39 options. For the third, 38, so on and so forth. We're going to keep going until we have 6 numbers up here. So 37, 36, and then 35, right? 1, 2, 3, 4, 5, 6. 6 numbers. And then we divide by the number we picked out. We picked out 6 out of the 40. We divide by that factorial. And again, this is more of the picture method. Not the whole formula. The formula will end up with the same answer. But definitely this is one way you can do it. Again, it's, listing out the different options you have to pick out all 6 of those students. But then to account for, repeats, because we don't care about the order at all, we divide by the number we picked out, factorial. And you can pop this into a calculator. I wouldn't worry about, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Simplify it all, we get 3,838,380. A lot of 3s and 8s. That's kind of interesting, right? That's a big number. But once again, if you're like, what the heck? Where are you getting this picture from? I don't get it. Don't worry about it. Use the formula. Because for the formula, all you need to know is, do you have a permutation or do you have a combination? Once you figure that out, you know which formula to use, and then you just need to determine N and R. So let's do that. So this is example 3, not 2. So our N is the total number. Well, there's 40 students. R, how many of the students are we picking out? Just 6 of them. Let's plug and chug. So we have 40, and we're choosing 6 students. So we get 40 factorial on top over 6 factorial times 40 minus 6 factorial. Let's simplify. 40 factorial divided by 6 factorial, 40 minus 6, 34 factorial. And once again, we can simplify using that nice little trick of peeling off numbers on top until we can reach this bigger factorial on the bottom. So we're going to peel numbers off until we get to 34 factorial. So 40, 39, 38, 37, 36, 35, And then, boom, we're at 34 factorial, which is going to cancel with the 34 factorial on the bottom. Gone. That equals what we just had, right? 40 times 39 all the way down to 35 divided by 6 factorial, which is what we had right here. And that's equal to 3,838,380. So once again, I'll just come back over here. You can use the formula. The formula is always straightforward, right? You just figure out your N, your R, you plug everything in, you're good to go. But if you really are, this is clicking with you and you're like, this is awesome, I get it, you can kind of draw it out this way. It doesn't matter. It's 2 different ways to approach these problems. You pick the way that works best for you. Hawks uses the formulas. So just be aware of that. And that's combinations. So I just have a little summary here. This week we covered counting. First we talked about that fundamental counting principle, which is about just counting the total number of possible outcomes. How many ways can this first thing happen? How many ways can the second thing happen? How many ways can the third thing happen? And we multiply. And then we kept using that idea to figure out permutations and combinations, right? We kept, what we did up here, this 49 times 39 times 38, so on and so forth, that's a fundamental counting principle. So that's kind of built in to all of these problems. Now, where students tend to struggle with this content is just figuring out which one's a permutation, which one's a combination. And it all comes down to order. So once again, with permutations, order matters. So some examples, passwords, right? Order definitely matters for a password. 1, 2, 3, 4, 5, 6 is not the same thing as 2, 1, 3, 4, 5, 6, right? Those are 2 totally different passwords. Not to make it confusing, and I hate this, there's sometimes a difference between the English language and mathematical language, but a locker combination is in fact a permutation. I know the word combination is in it. Again, this is an English language thing, but in fact, this is a permutation. If you've ever had a locker with, those locks on it that you got to spin, usually you'll have 3 numbers. They have these actually in the Setzer Center. No, not the Setzer Center, the gym. If you rent a locker at the gym, you'll get a lock for it, you get a combination, and you have to, twist the little knob for those numbers in order, right? Order matters. You can't just, if you have 21, 63, 76, well, it doesn't go that high. 21, 60, it doesn't, I don't know. Okay. Whatever numbers you want to pick. That was a bad example. But let's keep it simple. 4, 5, and 6. If that's your combination, you have to do 4 first, you have to do 5 second, you have to do 6 third. You can't switch it up. Otherwise, that lock will not open. Another example is, winning. Silver, bronze, silver, gold medals. Placing in a contest. Order definitely matters. Bronze and gold are not the same thing. First place and third place are not the same thing. Combinations, order does not matter. So, pizza toppings, right? Like if you order a pizza from Papa John's, you get pepperoni and sausage. Does it really matter if they put the pepperoni first and then the sausage? Or maybe they put the sausage on first, then the pepperoni? It doesn't matter. When that pizza is delivered to your house, it's a pepperoni and sausage pizza. Order does not matter. Poker hands. If you ever played poker, the hand you're dealt is the hand you're dealt. And you can rearrange that however you like, trying to, find a straight or a full house, whatever. Adding ingredients to a salad. Another example. Doesn't really matter the order you put them in unless you work at a restaurant and They have a certain recipe and they want you to put everything in order. We're not counting that. If you are ordering a salad at a restaurant, when you get that salad, all the ingredients are there, no matter what. It's the same salad, no matter the order they were put on. The ingredients were put on. Up here, the example we used for combinations was picking out a group from a larger group, where the order doesn't matter. So that happens. If you're picking a committee, perhaps, order doesn't matter when you're picking a committee. But if you're trying to elect officers, like president, vice president, treasurer, order matters. So it's all about the context of the problem. And when you're going through your homework, you just want to try to figure out if order matters. And just one other note, I think when you go through the problems, they'll probably have the topic for that problem. And so there'll be some problems that are strictly fundamental counting principle, and I think it'll say that in the name of the topic. And I should verify this, actually. But I know it's true in my other homework systems. I don't see why it wouldn't be true here in Hawks. But with the permutations and combinations, it'll say that in the topic. It's not going to say permutation only or combination only. It might say permutations and combinations, but that lets you know that you have to pick one of those. You got to figure out which one it is. All right. So don't forget to do the homework for this week. We're going to have a quiz at the end of the week. The quiz and the homework are going to be due on Sunday, the same day. And please let me know if you have any questions. Have a great week.